Welcome. I know a lot of you are going to be watching this from home, so we really want you to get involved and feel part of this session. So please put your questions in the Q&A window throughout the session. We've got experts on hand who will answer them as we go along throughout. If we've got a bit of time at the end, then I'll take some of your questions live. So this is a great chance for you to learn a bit more about SQL. Now, those of you who know a little bit about me probably know that I like SQL. But what you may not know is I also really like running. And occasionally these worlds collide and I end up doing something really crazy, like running the word SQL. So SQL's clearly doing weird things to my brain, but it turns out SQL's also really useful when it comes to answering questions you might have about a training program. Things like, are you sticking with your training program? And are you getting any better? And so on. We'll see how we can answer a couple of these during this session. But before we do, a warning. This presentation contains something that strikes fear into the heart of all developers, regular expressions. Now, before you start panicking and say, hang on a second, Chris, I thought this was going to be all about SQL. It's okay. There's going to be a lot of SQL in this talk. So stay calm. We're going to keep it nice and simple with the regular expressions. So, hi everyone, I'm Chris Saxon. I'm part of Stephen Feuerstein's Oracle Developer Advocate team and part of the answer team on Ask Tom. It's my job to help you get the best out of Oracle database and hopefully have a little bit of fun whilst doing so. So let's get started. Now, as I said, I like running and I used to do a lot of it when I was younger, but in recent years, I'd kind of fallen out of the habit a little bit. So sadly, myself, like probably most, if not all of you watching today, was under lockdown under recent months. And one of the few things we were actually allowed out to do here in the UK was your daily exercise. It's one of the few reasons you were allowed to leave the house. So I thought I'd use this opportunity as a chance to get back into the swing of running regularly. So I set myself the lofty goal of going running every single day. So that's the first question I need to answer here is, am I actually doing this? Well, what I really want to do is find chains of consecutive dates. So each day I run, I'll record the date, the distance, and the time. So I'll get a log that looks a bit like this. And as I said, I want to split it up into those groups of consecutive dates. So we've got the 4 groups here, first through the third, and so on. So before we jump into the SQL, let's just take a little step back and think about the problem, about what we're actually trying to do here, and find consecutive rows. Well, how do we know if rows are consecutive generally? Or how do we know if values are consecutive generally? Well, it's if the current value equals the previous value plus 1. We know 2 and 3 are consecutive because the difference between them is 1. Nice thing about dates in Oracle database is the unit of arithmetic is the day. You add 1 to a date, you'll get the same time the next day. So if we look here, we can see the 2nd and 3rd are consecutive because they've got a gap of 1. 7th and 10th are not consecutive because the gap is 3. Or more generally, they've got a difference that is not equal to 1. So we can use this fact as the basis for a pattern variable we can use in our match recognize clause. So what I'm going to do is use match recognize, the row pattern matching clause, to do this analysis. So a quick note on this. This comes after your table, and the table defines the input to match recognize. We'll do a bit of processing on it in there. That is where this lovely, scary regular expression comes in. Keep it nice and easy, I promise. And then that defines the rows and columns that will be in the output of the data set. So that will show what we see. So what we need to do is define some pattern variables, things we're looking for, and the regular expression involving these. So what we're looking for is consecutive values. So our pattern variable is the current value equal to the previous plus 1. So we'll put this in the define clause. Call it consecutive, call it whatever you want, but give it a nice meaningful name. Is the current run date equal to the previous plus 1? Next, we need our regular expression, and that goes in the pattern clause. So my pattern here is init consecutive star. Hang on. Some of you are probably looking at this and going, hang on. What's this init thing, right? I can see what consecutive means, so I've explained that, but init, that's not listed anywhere else in what I've defined. I've not defined it, what gives. Well, you can create any pattern variable on the fly in the pattern clause, and if they're not listed in the define clause, they are always true. So they match any row. So why do we need this? Well, let's think about the first row in the data set. We're on the first row, we try and match consecutive. We say, is the current row equal to the previous plus 1? Hang on, we're on the first row. there is no previous. It doesn't compute, right? So by having this always true init variable, it just gives us a convenient hook to start the group off without having to deal with null handling and other messiness. So we've got our initial row. We'll then move down through the data set and left to right through the pattern. So we check if the next row matches consecutively. Now we've got star here, so that means 0 or more matches of this. So hopefully I'll have a nice big long chain of like 10, 20, 30, whatever days where I go running every single day. Or maybe what I'll do is like I'll run today, take a break, run the day after, take a break. I could have consecutive runs of just one day, which is that init variable. So there could be 0 or more of these. So if we look at how this matches the data set, we start with our first row, 1st of April, matches the always true init. Down to the next row, left through the pattern, does it match consecutive? Well, 2nd is consecutive with the 1st, so it matches that. Similarly for the 3rd. We then go down to the 6th. Now, this is no longer consecutive with the 3rd, so we end the first group and go back to the start of the pattern and search all over again, starting again with our always true init. We then ask, is the 7th consecutive? Yes, it is, and we continue on through the rest of the data set, matching up the variables like this. So this gives us the engine of our statement, our pattern variables and our regular expression. But still something missing here. I said, is the current value equal to the previous plus 1? But I haven't actually defined what previous means, right? Now, hopefully, if you've got a select statement without an order by, well, the database is free to return the rows in any order it wants. It's the same with match recognize. If you've not got an order by, it can process the data in any sequence. So we want data sorted by date, so we need to do order by run date. Now note, this is a technically optional clause in the sense that you will not get an exception if you exclude it. Your query will still complete. But I strongly urge you to consider this a mandatory clause in the sense it's almost always a bug waiting to happen if you exclude it. So we've got our engine, we've defined how we're walking through the data set. Finally, we want to say which columns we want in the output. We do that with the measures clause. So what I want to see is the first date in each group and how many rows there are. So we do measures, first run date, count star. So first does like a little bit like what it says on the tin, returns the value for that expression for the first row in the group. So in this instance, it's always going to be those variables or those rows that match the init variable. Count is just a count star function we all know and love. How many rows are there in the group? So we've got our clause here. We can now run the query and we'll get an output that looks a little bit like this. And we can see, I'm not really sticking with my run every single day plan here, am I? Okay, well, might need to think about that a bit. Okay, so that's an overview of how match recognize works. At this point, I'm going to jump over to a demo so you can see it in practice, see it for real. Nothing like a live demo to prove that things really work. So here's my running log, and I've loaded it up with a bit more data, so the analysis is a bit more interesting. And here's my clause, find all the consecutive rows, and we get some output that looks like this. Now, as I said, I'm not really sticking with my run every single day plan here. I'm managing, well, at most 6 days in a row, and most of the time I'm not even getting close to that. So, it's not good. And the fact is, I'm very unlikely to go running every single day for an extended period of time, right? Some days I'll do other forms of exercise, you need rest breaks, and some days, frankly, I just can't be bothered, right? So running every single day for an extended period of time is it's frankly unachievable. It's very unrealistic. And it's bad to set yourself completely unrealistic goals. It's better to set yourself smaller, more achievable goals, things you're actually likely to be able to do. So rather than ask, did I run, or what's my longest chain? Did I run every single day? What I want to do is carve this up into groups of 3 consecutive days. So 1 day followed by 2 more consecutive. So we can do that easily just by changing my regular expression here. So I've got init consecutive star. I want init followed by exactly 2 consecutive rows after that. So we can change this star here to this lovely little curly bracket syntax, which find exactly 2 occurrences of regular expression of that variable. And we can see we now split it up into all those groups of 3. Now notice from the 17th of April, I actually ran 6 days in a row, 2 groups of 3. We start with our init variable, match the 2 Following that, we then end the first group because we're looking for exactly 2 after that original one, and then start searching again. Init followed by exactly 2 consecutive. So we can see what's going on here. We get a nice summary of what's happening. But what if I want to see all the individual rows? I want to see each individual date and how far I went and my time and so on. But how can we do that? Well, Match Recognize has this implicit clause of 1 row per match. This works a bit like group by, consolidates all the rows in a chain down into 1 in the results. If we want to see all the individual rows, we can set that to all rows per match. And we'll run that and we can see now we've got all the individual rows that match the pattern. So you can see here, we've got various chains where I ran 3 days in a row, but there's this big gap from the 3rd through to the 13th. What happened to those days, 6th, 7th, and 10th, where I went for a run? Like I say, we only get rows in the output that match the entire pattern. 1 row followed by exactly 2 consecutive. 6th and 7th and 10th do not meet that criteria, so they do not appear in the results. This can create an interesting problem when you're writing this. If somehow you completely stuff up this regular expression so it matches no rows, you're going to get no rows in your output. Okay, which can make it, when you're writing these queries and or debugging them, a bit tricky to figure out what exactly is going on here. So rather than see all rows per match, what I want to do is see all the input rows. And we can do that by adding this with unmatched rows clause. So that will show you the entire input data set, even if it didn't actually match the complete group. While doing that, I'm also going to have this classifier function that returns the name of the pattern variable that that particular row matched. So either init or consecutive in this example. I've also got 2 counts in here, and that's to show you a subtle thing. Count on its own is actually the running count in the group. Final count is the overall total for the group. So it'll always be 3 for complete groups in this instance. So let's run that query, and there we go. We can see now we've got all the individual rows. So note, those 3 rows that didn't match the entire pattern, well, they've got no values for the measures clause. You might go, well, hang on, 6th of April, always true in it. Why isn't it matching that init variable? Like I say, has to match the entire pattern. So, and without that, it's not going to get tagged. So a bit of advice, if you're writing complex match recognize expressions like this, try and build them up gradually. If you've got 4 or 5 pattern variables, add them one at a time to your pattern. Otherwise, that way, if you make a mistake, you can see very easily where the chain is broken. It's not always possible to do this, but where you can, try and add the variables one by one. And then if you suddenly make a mistake, go, okay, I see where the problem is, and work around it. Quickly on the count versus final count. So we can see days so far, that is the running total, and final is the overall total. So really useful. I would say, remember, the default output of match recognize is 1 row per match. And that's often what you want to see in your actual report or the final query, the results of it. When you are writing or debugging it, I would really strongly recommend you always slap these clauses in, classifier function and the all rows per matched with unmatched rows, so you can see what's going on and strip them out later if that's not what you want in your final output. Okay, so that was a brief little demo on how that all fits together. So let's just jump back over, and hopefully you think, wow, this is pretty cool. You learn some cool things here in Dev Live, or there's other cool things you've seen today, and you go like, yeah, this is brilliant. I'm going to try this out. And whenever you come to any WebEx or technology session or virtual conference, it's a good idea to share that knowledge with the rest of your colleagues. You tell other people on your dev team, this is a really cool thing. Let's give this a try. Or maybe you're actually got a problem where you're searching for consecutive rows now. After all, it's a really common question that crops up. Ask things like, how many consecutive days did we do a successful deployment? How many consecutive days did we have full availability on the website? How many consecutive days did each customer visit our website? So on and so forth. Really common to ask this type of question. So maybe you're going to go, actually, I can use this now. I can implement this. And then, in your code review, or, your fellow developers looking at this are going, oh, what's this thing? Explain it to us. How does this work? So either way, hopefully you'll go out there and explain this to other people on your team. At which point, some wise developer on your team will probably look at this and go, hang on a second, can you make this reusable, right? Can you take this logic and extract it and apply it to other problems? After all, I said, finding consecutive rows is a really common question, something that crops up really often. Can we take that match recognize clause and then apply it to other tables? At which point you're just kind of like, yeah, let me get back to you on that, right? It's like, yeah, it's not easy, right? And this strikes at a common criticism I hear of SQL that I believe has some validity. It lacks composability, the ability to define SQL fragments, parts of a SQL statement, which you can then build up into larger statements. Now, this isn't entirely true. You can, of course, make this particular query reusable by sticking it in a view. And then we can join that view in other queries and so on and so forth. And if this is the only use case we have, let's imagine you're building a Strava or Runkeeper type clone where you want to track your users' activity, see how many days they go running and that kind of thing. This is fine. But what if we want to make this logic generic, find the consecutive rows? What we want to do is essentially be able to pass in any table name in here. This is where things get a little bit more clunky, a lot more fiddly with SQL. You have to start doing something like this. Open up a ref cursor, pass in the table name, and concatenate it in. And if you watch Connor's session, you'll know as soon as you start having string concatenation, you're at risk of SQL injection. And it's just like, okay, yeah, it's not good. You might go, well, why don't we just bind the table name? Why can't we do that? Well, the thing is, you cannot bind identifiers. You can't bind table names, column names, that kind of thing. You have to do something like this, do some sanitation and make sure it is in fact a genuine table name in your database. So it's a bit clunky, right? And we've got a ref cursor here. To make this really reusable, we've got to turn it into a table function or something like that. It's a bit messy. It's easy to make a mistake here. A lot of people, sadly, unfortunately, don't know that they need to do this to protect against SQL injection. It's all just a bit of a faff, right? It's pretty tricky to make generically reusable SQL fragments, which you can then build up and apply generically, right? Wrong. We now have SQL macros. So what these do is they define a SQL fragment, part of a SQL statement, which when the database passes your query, it resolves the macro. So this is a PL SQL function that returns some text, becomes part of your SQL statement, and then that is what is executed by the database. So SQL macros come in two flavors, table and scalar. So what's the difference between these two? Well, table macros you use in the from clause in place of a table or a view or whatever, or a subquery. Scalar macros you use everywhere else. Basically everywhere else it's legal to use a PL SQL function. So the select clause, the where clause, the order by, so on and so forth. So we've got these two different types of macro. I'm going to be focusing on table macros for the rest of this presentation. A couple of reasons for that. First up, they're just a bit more interesting. There's some cooler things you can do with table macros. But secondly, and more importantly, SQL macros originally slated to be a 20C feature, but we have backported SQL macros, table SQL macros only to 19.6. So if you're lucky enough to be running 19C, you can use table macros today. Okay, so they are now available for you. Scalar macros, you are going to still have to wait for the next release of Oracle Database, sadly, but table macros, provided you're fully up to date, you can use today. All right then, so that's the overview. How do we actually write a SQL macro? Well, what they do, as I said, is return a SQL fragment. So I'm going to keep it simple for the first example, write a generic top N function. So pass in a table name and get that number of rows from the table. And we'll start off by writing that query, a fetch first clause, fetch first this number of rows only from the table. Now, we're not actually executing this SQL statement. We're returning this fragment. So what we need to do is turn it into a string. Okay, so now we're returning just text. and the function we create will return a varchar2, which is a Sql macro. And our parameters to that are the number of rows and the table. So how does this work? How does the database resolve this into an actual SQL statement? Well, when you call the Sql macro, the database does a find and replace of the exact text of exactly whatever those parameter text is in your SQL statement. So it doesn't, evaluate functions, it doesn't peek at binds or anything like that. You've got a bind variable for the number of rows. The bind variable is what is in the function that is executed by the database. So if we call this top end function and we pass in 5 from employees, what we're going to get is select from employees, fetch first 5 rows only. So it's fairly straightforward and obvious there. What if we want to do something different? We just heard Connor talking about the importance and brilliance of bind variables. We want to use a bind variable for the number of rows. So we pass bind jobs table. So we're going to select from the jobs table, and what we're going to get is the fetch first bind rows only. So this is exactly what the SQL statement is going to be. We don't peek at that bind variable and go, oh, it's 2, we'll put 2 in there. No, it is still a bind variable in your final SQL statement. Same applies if we pass a function instead. So that's a quick overview. We can now build my generic get consecutive rows function, pass in a table and the column that we're searching for consecutive values on. So at this point, I'm now going to jump back over to the demo again so we can see how this all works in practice. So start off with the top end example. So you see, we're returning this as text, as a string. And now I can pass in running log, fetch the first 5 rows from that. We can do that. I can also pass in a bind variable. So I've got 10 there. So I'm going to get 10 rows from it. Run it again. 1 row, we're going to get 1 row. That's because the bind variable is what is in the final SQL statement. You could also do crazy things like this, pass in a subquery. So here I'm going to get 2 rows from the table. Or I could pass in a function, dbms random.value, random value between 1 and 10. So if I run this a few times, hopefully we'll see we get a slightly different number of rows each time I execute it. So you can see each time getting a subtly different number of rows. So what's actually going on? How do we know what the database is actually executing? Well, we've got this handy little thing, DBMS utility expand SQL text. And this shows you the final statement that's run by the database. So I'll do this with dbms random.value. Hopefully it will make it a bit clearer what's going on here. So we'll run that and we get some output like that, nice big long string. So let me just get it, do a quick format on it. So we can see we've got some nested subqueries. Interesting thing is you can now also see how Oracle Database implements fetch first. It stuck a row number function in there instead and generated this row number limit column. So if we look for that further down, we see this row limit number. We're checking that that is less than dbms random.value 1 to 10. Okay, we've got the exact text of that function name in your final SQL statement. It hasn't executed it and gone, oh, okay, 1, we'll use that. No, it is exactly the text you have passed to the database that is actually in your final SQL statement. So this is pretty cool. We can now get, here's what I made in case there was a problem there. So we can now pass in any table name we want here. And the thing is, this has to be a real table in the database. So if I pass in invalid table, doesn't exist in this schema, going to get an exception. There is no invalid table in this database. We're also checking that this is in fact a real table. So if people want to do some funky SQL injection type stuff where 1 equals 1, so we've got this string, well, it's not going to work because we're expecting an identifier, a table name here, not some text, a string. Has to be a real table name. Now at this point, some of you might get a bit clever and go, well, actually, we can take that and make it, an identifier by double quoting it like this, but it's still going to fail because I've got no table in my database called running log where 1 equals 1, so on and so forth. And even if I did, what we would be querying is that exact table, not trying to interpret this and make this part of the final SQL statement. So we are much safer here and very hard to write hackable code, or it's much harder to write hackable code using these Sql macros. So let's get to our generic consecutive rows function. We've got our table and the column here. Now this column's type uses a column pseudo operator. So that's a comma separated list of values. So basically an array of the columns that we want. Of course, we're only looking for one column, so we'll always get the first. And in order to do that, we do have to concatenate the table name in there. So we can do that because there isn't really a native way to bind an array to a single value. So we're getting the first element of the array. And now we can do our function, call our function, searching for the consecutive run dates, and there we go. Exactly the same output as we had with that original match recognize function, because it's the same thing. We're doing exactly the same thing. Now, some of you might be a bit concerned at this point and going, hang on, string concatenation there's a problem, right? Now, these columns have to be the names of real columns in this table. So dummy belongs to dual, but doesn't belong in running log. So if we execute that, it doesn't exist, so we get an error. Equally, if I try and pass a string in there for that, it's not going to work. So it's much harder to write unsafe code using these Sql macros than the other approaches you would use before without it. And as I said, this is now generic, dynamic. We can pass in any table or any column. So I can search for consecutive values 4 times. Not quite sure exactly what this means, but anyway, we'll run it anyway. And we can see, so I've got 282. So 2 rows for that. So that means I ran, one of my runs was 280 seconds and one of them was 281. Similarly, 303. So we have 300, 301, 302, so on. So we can pass in any column here. We can do that logic on the current value equal to the previous plus 1. So dates and numeric values. We can also pass in any table. Now, when I say a table, it could be a real physical table, could be a view, or could be a named subquery. So I can use common table expression to define some rows on the fly, pass that in, and we can see we split it up into those 2 consecutive groups there. So groups of consecutive chains. So this is really powerful. We've now taken that logic, find consecutive rows, and we can apply it to any table and any column with an appropriate data type. Awesome, fantastic. Alrighty then, so let's just move back over, recap what we've looked at here. So we started off looking at match recognize. And as I said, what we can use that to do is search for a regular expression across rows. Finding consecutive values is a really common situation where you might want to do this, but when else would you want to use it? Well, classic example use case or idea is stock trading. Stock traders are always looking for these kind of patterns in the changes in price, or data traders are. Price went down a day, up a day, down a day, up a day. So we get this little W pattern in the data set. It's quite tricky to write that kind of query using standard SQL. Either you've got to have subqueries on subqueries on subqueries, or join to the same table multiple times. Either way, it's just a bit messy. And then if we tweak the requirements slightly and say, instead of down a day, up a day, down a day, up a day, we go down 2 days, up 2 days, down 2 days, up 2 days. It's really fiddly to do that. With match recognize, we can define 2 pattern variables, up and down. Up, his price is greater than previous price. Down, his price is less than previous price. And just our pattern is up, down, and however many occurrences we need with our regular expression. So very powerful, very easy to search for sequences of different events across rows. Much easier than a lot of traditional SQL approaches. So this is really cool. But as I said, quite often, or previously, it is very tricky to make this logic generically reusable and apply it to other tables, other columns, and so on and so forth. So now, at last, we have Sql macros that allow us to do this. These are reusable SQL fragments. They return the text or part of the text of a SQL statement at parse time, and the database figures out what this is and resolves it, becomes part of the final SQL statement, and it is as if the function does not exist. We're just running SQL at that point. So we've got these really cool features, match recognize and Sql macros. So by combining these, we can bring SQL firmly into the 21st century and unlock pure SQL awesomeness. Oh yes, fantastic. So you're probably going to want to know a little bit more about this. So I've got some further reading, some further use cases I've looked at for doing this, things like customer retention analysis, bin packing problems, and so on. So check that out if you want to look at more use cases for pattern matching. you want to know a bit more about SQL macros and how they work, check out this blog here. There's a lot of great examples showing how they work, and you can do it to use temporal joins and so on. So, we've got time. So at this point, I'm going to take some questions and see if we've got any questions come in. So let me just stop my share a second and bring that up and take a look at what's going on here. All right then, so we've got a few questions. So first question, which versions and offerings of Oracle database are these features in? So good question. So pattern matching. So this is a 12C feature. So it has been around for, 7 years now, quite some time. So plenty of time to bed in and get used to it. So pattern matching has been around a long time. SQL macros, however, much newer. As I said, originally they were slated to be a 20C feature, but the table macros that we looked at have been backported to 19.6. So provided you're on the latest fully patched 19C, you can then play around with and see with table macros. Sql macros, you are still going to have to wait for to actually get them up and running for full. We do have 20C available in the cloud for preview if you want to play around with it. If you've got some free credits or you're willing to spend a little bit of money, you can play around with that. But otherwise, generally, you're going to have to wait for the next release. In terms of offerings, which editions of Oracle Database, both of them are available in every offering. So that means they are both in standard edition, okay? Also in all cloud services that meet the minimum version requirement. So whatever copy of Oracle Database you're using, as long as the version is high enough, you can use both of these features. Okay, so classic question. What is the performance of these features? Okay, so I'll take each one separate. So SQL pattern matching. First thing to note is that table view subquery is the input to match recognize. So run your query on its own without the match recognize clause. If it takes 10 minutes to run that query, then guess what? It's going to take about 10 minutes to run it with the match recognize clause on top, or at least 10 minutes on top. So figure out your base SQL tuning. But what about match recognize itself? Well, the work here all comes from that regular expression. If you look in your execution plan, you'll see a little line that says match recognize and either buffer or sort. If that is all you see, start to get worried, okay? This means that the regular expression can get stuck doing something called backtracking. I don't have time to explain what that means in more detail, other than say, look up regular expression and backtracking if all you see is match recognize and buffer or sort. If, on the other hand, what you see is match recognize deterministic finite auto, you are in a nice happy place where backtracking is not a problem for the regular expression, and the database can process it exceptionally efficiently. There was a demo done at Open World a few years back where we processed something like 1 billion rows in a couple of seconds using match recognize. So provided backtracking is not a problem for pattern matching, it's nice and fast. If it is, start to worry, think about how you can rewrite it, and as always, test and benchmark. When it comes to SQL macros, the thing to note here is this is a parse time only thing. Once you parse the query, it's like they're gone. They're no longer part of the SQL statement. So they're great. And this solves a common dilemma with PL SQL. So with PL SQL, you can create reusable logic units, calculations such as currency conversions. But if you call those in SQL, there's a problem. Context switch, right? And if you've got large data sets, this context switch can really slow your statement down. So you've got a bit of a dilemma, maintainable code or performance. Which do you prefer? Which is more important? Often you have to decide on a case-by-case basis. SQL macros resolves this dilemma. You can now have your maintainable, reusable SQL macro, SQL function, but you no longer have that context switch when you actually call it. So it's, as I say, it's gone. It removes the overhead of the context switch for PL SQL. So Sql macros, we've got them, very good for performance. All right then, various other questions that have come in. Do SQL macros work with synonyms and remote tables through database links? So the thing to remember here is you are passing in a table name and so on. So it is making that part of the final SQL statement. So in terms of synonyms, it's if if it was a legal query to do select star from synonym, whatever it was, then it should be able to do it. Database links, I would have to double check on that to see exactly, make sure there's no limitations there. But basically, it's taking that thing, that table, that view, whatever it is, and making it part of your SQL statement. So if that's a valid SQL statement, then it should work. Okay, so next question. Can I run SQL macros on live SQL? So sadly, not at this moment, or as far as I'm aware. Last I checked, live SQL was still on 19.5, not 19.6. So hopefully we will have that updated soon, so we will be able to play this. I know a lot of you are probably really excited and keen to try this out. So hopefully we will have that soon, but not as I know at the moment today. Let's see. And we've got a few other questions. All right then, so how do I know when I should use Sql Path Matching? Okay, so this is a good question. So I said like searching for consecutive rows, and you go, okay, I can see that use case, but when else do I want to know, or what's the key thing I should be thinking about to go, maybe I should be using match recognize here? What you are looking for is a sequence of different events across rows, okay? And I talked about, that W pattern with stock trading, but it can also be useful for things like order statuses or invoice statuses. Let's say you've got a history for statuses for an invoice, so they were created, paid, and then you want to find the ones that were cancelled and refunded within 7 days, for example. So you've got a series of different rows. Well, really easy to do that with match recognize. You've got your variable created and it's paid, created, paid, refunded, and they're within 7 days of when it's created or whatever you're checking. So sequences of different events. And often the clue that you should probably be looking into this is if you've got subqueries based on subqueries, based on subqueries, based on subqueries, so on and so forth. So you're nesting lots and lots of things. Or if you're joining to the same table over and over again. And those are key indicators that you should probably be thinking about using those. And also, one other thing we can use this for is bin packing style problems. So loading goods onto containers, right? You've got these containers, you've got to load them up to some maximum weight limit. It's a hard computer science problem, which means there's no known solutions which are guaranteed to be both fast and optimal. Now, unsurprisingly, match recognize can't guarantee either of those, but provided you can accept some constraints, like a first in, first out ordering, just sorted by date or something like that, really easy to write this type of query using match recognize to find out what's actually going on. So you can check that out, play around with it, and see how that all works. Okay, let's see if we've got another question I can see. What are the type of value in the rows? Var, and varchar2 or others too? So are you asking, if you're asking what the type of the values are in terms of the parameter values, you can define what type they are. So we can say, we had number of rows, that was a bind variable, which is type number. You can say it has to be a numeric data type. So we do have type checking in terms of in the input. The table, we use that DBMS TF table T. That's a special thing. If you played with polymorphic table functions, which came in 18C, it's the same package, same type there, same for columns. So you can declare the type of the input arguments, and the output, well, it's like I say, it's just SQL. So it's whatever the type of those columns, expressions, whatever they are, would be as well. So it's, you control the type of the input, the output is whatever the rows and columns of the output would be too. Okay, so I think we're about all I've got time for at the minute. So thank you, thanks for the questions. Let me just go back and finish that up. So last little glimpse at this slide here. All right then, so just to kind of There we go. So please stick around for the next sessions. We've got Sanjay and Paul talking about how you can build microservices using Oracle database. And we've got the always excellent Maria Colgan saying how you can scale Oracle Autonomous Database to even the most extreme workloads. I really hope you enjoyed this, but more importantly, I hope you learned something. Go out there and bring SQL firmly into the 21st century. Stay safe, and I hope to see you again soon. Goodbye.